Picture this. If we shrunk the entire universe down so that Earth was no bigger than a single grain of sand, how massive would the observable universe be in comparison? Would it fit inside an orange, a watermelon, maybe even a basketball? The truth is far more staggering. In this scale, the observable universe would dwarf even the Sun, not just slightly, but more than 30 times larger than our star itself. That's the kind of mind-bending scale we're about to explore. This isn't just numbers and distances. It's a journey into perspective, a way to feel the immensity of space in your bones. Because when you realize how small we truly are, you'll never look at the night sky the same way again. Earth feels enormous to us. At 8,000 miles in diameter, it takes about 45 hours to fly around its circumference in a commercial airliner. That's huge by human standards. But in the cosmic hierarchy, Earth is barely a speck of dust. Take Jupiter, the giant of our solar system, 11 times wider than Earth, stretching 88,000 miles across. And then there's the Sun, our blazing host star, at a jaw-dropping 865,000 miles in diameter. That's so vast it could swallow 1.3 million Earths inside it. Numbers like these are hard to grasp. So let's shrink everything down into something familiar: food. Mercury becomes a peppercorn. Earth and Venus shrink to cherry tomatoes. Mars, a blueberry. Saturn turns into a grapefruit. Uranus becomes an apple. Neptune a lime, and Jupiter a full watermelon. Now, if Jupiter is a watermelon, what's the Sun? Surely a pumpkin or maybe a giant jackfruit. Wrong. The Sun is so colossal that in this scale, it wouldn't even be a fruit. It would be closer to the size of a skyscraper towering over the pavement. Imagine a tiny tomato lying next to a skyscraper-sized vegetable. That's Earth compared to the Sun. And yet, this is only the beginning. Earth orbits the Sun at 93 million miles away, 1 astronomical unit AU. To drive that distance at 60 mph, you'd need 176 years without bathroom breaks. Neptune, the furthest main planet, sits 30 AU away, or 2.44 billion miles. But even Neptune isn't the edge. The dwarf planet nicknamed Far Far Out orbits at 132 AU, 12 billion miles away, and takes about 1,000 years to complete one orbit. Still, that's not the true boundary. The Oort cloud, a vast shell of icy debris, marks the gravitational edge of our solar system. Its inner edge begins somewhere between 2,000 and 5,000 AU, while the outer edge stretches to 100,000 AU over a light year away. That's 5.88 trillion miles. Let's shrink again. Imagine the solar system scaled onto a football field. The Sun is a dime-sized sphere on the goal line. Neptune is a sugar grain 60 yards away. Far Far Out would be invisible, smaller than strands of DNA, sitting 2.5 football fields away. And the Oort cloud. It would lie 1,600 football fields away, farther than Philadelphia if our field was New Jersey's MetLife Stadium, or about 1,400 soccer pitches for UK viewers. That's just our solar system. And here's the kicker. It's only one of hundreds of billions of stars in the Milky Way, each potentially with its own planetary system. So how does our solar system compare to the Milky Way? Shrink the solar system down to the size of a US quarter in your palm. The Milky Way in this scale would be the size of the entire United States. Think about that. A tiny coin in your hand versus a continent-spanning galaxy. And remember, the Milky Way contains around 400 billion stars. Each one could host its own planets, moons, and mysteries. Our Sun feels enormous, but compared to other stars, it's a baby. Sirius, the dog star, shines 50 trillion miles away, nearly twice the size of our Sun. Aldebaran, a red giant, is 45 times larger. Betelgeuse, a supergiant, stretches up to 1 billion miles across. And then there's Uy Scuti, once thought to be the largest confirmed star. At about 1.26 billion miles in diameter, it could engulf Jupiter's orbit. If the Sun were a basketball, Scudi would be the size of a cruise ship. And even bigger candidates like Stephenson 218 have been suggested, though estimates vary, and it may not hold the record. Pause for a moment. Imagine standing on Earth, a cherry tomato next to a skyscraper sun, inside a galaxy the size of a continent, surrounded by stars so massive they could swallow our solar system whole. It's humbling. It's terrifying, and it's beautiful, because in this vastness we still get to exist, to look up and to wonder. We've only just begun. If our solar system is a quarter compared to the United States, what happens when we zoom out to compare the Milky Way to the entire observable universe? The numbers ahead will shatter your imagination. Stay with me, because in Part 2, we'll journey beyond galaxies into superclusters, black holes, and the largest structures ever discovered. And trust me, you'll want to know just how small we really are. We've already seen how stars like Betelgeuse and Scudi make our sun look like a candle next to a bonfire. But here's the thing, even those colossal stars are just tiny dots inside the Milky Way. And the Milky Way itself, it's only one galaxy among billions, so let's zoom out again. Brace yourself, because this is where the scale of the universe starts to feel almost unbearable. Our Milky Way stretches about 100,000 light-years across, containing hundreds of billions of stars. Yet it's not alone. Our closest neighbor, the Andromeda Galaxy, is even bigger, roughly 200,000 light-years wide, with 1 trillion stars. Together, the Milky Way, Andromeda, and dozens of smaller galaxies form what astronomers call the local group. This collective spans nearly 10 million light-years. To put that into perspective, if the Milky Way were a penny, Andromeda would be a safety pin 2 feet away. And here's the kicker. The light we see from Andromeda tonight left that galaxy 2.5 million years ago. We're looking back in time, seeing it as it was when early humans were just beginning to walk upright. But the local group is just one neighborhood. Zoom out further, and we find ourselves inside the Virgo supercluster, a sprawling structure containing at least 100 galaxy clusters. Each cluster holds hundreds of thousands of galaxies. The Virgo supercluster stretches 110 million light-years across. Its volume is 100 billion times that of the Milky Way. Imagine the Milky Way as a single grain of sand. The Virgo supercluster would be the size of a guitar, and within this supercluster lies one of the largest galaxies ever discovered, IC 1101. With a diameter between 43,000 and 550,000 light-years, it dwarfs the Milky Way. IC 1101 contains hundreds of billions of stars, and at its core lurks a black hole so massive it defies imagination. Black holes are regions of space so dense that not even light can escape. They form when massive stars collapse, compressing matter into an infinitely small point. The closest known black hole to Earth is about 1,560 light-years away, far enough that we're safe. But at the heart of IC 1101 lies a supermassive black hole, weighing tens of billions of times the mass of our Sun. Some estimates suggest up to 100 billion solar masses. And then there's TON 618, one of the largest black holes ever found. Located 18 billion light-years away, it's about 60 billion solar masses. Its event horizon, the boundary beyond which nothing can escape, spans 240 billion miles. That's wider than the orbit of Neptune. Think about that. A single black hole larger than our entire solar system. Now, let's zoom out again. The Virgo supercluster is just one branch of a much larger structure, the Laniakea supercluster. This cosmic web stretches 520 million light-years across and contains around 100,000 galaxies. Its mass, is 100,000 times that of the Milky Way. Imagine the Milky Way as a canoe. Laniakea would be the size of a city. And here's the astonishing part. Our galaxy is being pulled through space toward a mysterious gravitational anomaly called the Great Attractor. We're hurtling at 134,000 mph, yet we don't feel a thing. Beyond Laniakea lies the Pisces, Cetus supercluster complex, stretching over 1 billion light-years. It's part of the cosmic web, vast filaments of galaxies and dark matter weaving the universe together. But the largest known structure is the Hercules, Corona Borealis Great Wall. This titanic filament spans 10 billion light-years, covering more than 10% of the observable universe. It's so immense that its existence challenges the very foundations of the Big Bang theory. How could something so large form so quickly in the early universe? Scientists are still debating. Pause here. We began with Earth as a cherry tomato next to a skyscraper sun. Then we zoomed out to galaxies the size of continents, superclusters the size of cities, and black holes that could swallow solar systems whole. Now we're staring at structures so vast they stretch across billions of light-years, walls of galaxies that defy our understanding of physics. It's overwhelming, it's terrifying, and yet it's exhilarating. Because every time we zoom out, we discover that the universe is bigger, stranger, and more beautiful than we ever imagined. And here's the question. If the observable universe is this vast, what lies beyond it? In Part 3, we'll explore the edge of the observable universe, the mysteries of infinity, and whether our cosmos might just be one of many, a multiverse. Stay tuned, because the next step will take us beyond the horizon of what we can see, into the unknown. We've already seen galaxies the size of continents, superclusters stretching hundreds of millions of light-years, and black holes that could swallow solar systems whole. But here's the question that keeps astronomers awake at night. How far does it all go? The answer takes us to the very edge of what we can see, the boundary of the observable universe. And beyond that, well, that's where imagination collides with mystery. The observable universe is the sphere of space we can see from Earth, limited by the speed of light and the age of the cosmos. Light travels at 186,000 miles per second, but the universe is 13.8 billion years old. That means the furthest light we can detect has been traveling for billions of years. But here's the twist. Because the universe has been expanding all that time, the edge of the observable universe isn't 13.8 billion light-years away. It's about 46 billion light-years in every direction, making the diameter roughly 93 billion light-years. Think about that. A sphere so vast that within it lie hundreds of billions of galaxies, each with billions of stars. More stars than all the grains of sand on Earth's beaches. Let's shrink again. If the Milky Way were a grain of sand, then the Virgo supercluster would be the size of a guitar. Laniakea would be a canoe. The Pisces, Cetus supercluster complex would be a city bus. The Hercules, Corona Borealis Great Wall would be taller than the Statue of Liberty. And the observable universe. It would tower higher than the Burj Khalifa in Dubai, the tallest building in the world. That's the scale we're talking about. From a grain of sand to a skyscraper that dwarfs everything we know. The furthest galaxy we've detected is HD 1, seen as it was only 324 million years after the Big Bang. Physically, it now lies about 33 billion light-years away. When we look at HD 1, we're peering back into cosmic history, possibly glimpsing some of the universe's very first stars. And beyond HD 1 lies the cosmic horizon, the point beyond which light hasn't had time to reach us yet. It's not that nothing exists past that boundary. It's simply that we cannot see it. So what does the universe look like? Is it flat, round, or something stranger? Some measurements suggest the universe is flat, expanding in parallel lines forever. Others hint at a curved geometry like a sphere. And some theories propose a torus or donut shape where parallel lines wrap around into curves. Imagine drawing straight lines on a piece of paper, then taping the edges together into a cylinder and finally bending it into a donut. The lines remain parallel, but the universe now has curves. Delicious and mind-bending. Here's the most staggering thought: the observable universe is not the whole universe. It's just the part we can see. Astronomers estimate the actual universe could be at least 250 times larger, possibly infinite. That means everything we've described so far, galaxies, clusters, superclusters, filaments, even the Great Wall, might be just a tiny fraction of a much larger reality. And then comes the wildest idea of all: the multiverse. Some theories suggest our universe is just one bubble in a vast cosmic foam, with countless other universes existing alongside ours. Each could have different laws of physics, different stars, even different versions of us. Pause here. We began with Earth as a cherry tomato next to a skyscraper sun. We zoomed out to galaxies the size of continents, superclusters the size of cities, and black holes that could swallow solar systems whole. Now we're staring at the edge of the observable universe, a sphere 93 billion light-years wide, containing more stars than grains of sand. And beyond that, possibly infinity. Possibly other universes. It's humbling, it's terrifying, and it's awe-inspiring, because in this vastness we still get to exist, to wonder, and to ask, what does it all mean? We've reached the edge of the observable universe, but the real question isn't just how big it is, it's what this immensity means for us. In Part 4, we'll explore the philosophical side, our place in the cosmos, the possibility of other universes, and why being small might actually be the most extraordinary gift of all. Stay tuned, because the next step isn't about numbers. It's about meaning. We've traveled from Earth as a cherry tomato next to a skyscraper sun, through galaxies the size of continents, superclusters the size of cities, and black holes that could swallow solar systems whole. We've stood at the edge of the observable universe, a sphere 93 billion light-years wide, containing more stars than grains of sand on every beach on Earth. And now comes the most important question: what does all of this mean for us? It's easy to feel small, even insignificant, when faced with such immensity. After all, our entire planet is just one speck orbiting one star in one galaxy among billions. But here's the paradox: our smallness is what makes us extraordinary. Out of all this vastness, we are here, conscious beings capable of looking up, asking questions, and daring to understand. Think about it. The atoms in your body were forged in ancient stars. The iron in your blood, the calcium in your bones, the oxygen you breathe, all of it was born in stellar furnaces billions of years ago. You are literally made of stardust. So when you gaze at the night sky, you're not just looking at distant suns. You're looking at your own origin story. The immensity of the universe can feel overwhelming, even terrifying. But it also offers comfort. The problems that weigh us down, deadlines, arguments, fears, shrink when compared to galaxies spanning millions of light years. The fragility of life becomes precious when we realize how rare consciousness might be in the cosmos. And the act of simply existing, here and now, becomes miraculous when set against the backdrop of infinity. Perspective doesn't erase our struggles, but it reframes them. It reminds us that we are part of something vast, ancient, and beautiful. We've seen that the observable universe is 93 billion light-years wide. But beyond that horizon, the cosmos may stretch endlessly. Some scientists estimate it could be at least 250 times larger. Others believe it might be infinite. And then there's the possibility of the multiverse, countless other universes, each with its own laws of physics, its own galaxies, its own stories. If that's true, then our universe is just one chapter in an endless library. And we, tiny as we are, get to read a page of it. Here's the truth: we are small. But smallness doesn't mean insignificance. A single grain of sand can hold the memory of an ocean. A single spark can ignite a fire. A single human mind can imagine galaxies billions of light years away. Our scale may be tiny, but our capacity for wonder is infinite. And that's what makes us extraordinary. So next time you look at the stars, don't just see distant points of light. See the story they tell, of creation, of scale, of mystery. See yourself, a being made of stardust, standing on a fragile world, daring to understand the cosmos. The universe is vast beyond comprehension, but within that vastness you are here. You are alive. You are capable of awe, and that perhaps is the greatest miracle of all. We've journeyed from Earth to the edge of the observable universe, but the story doesn't end here. The next frontier isn't just about discovering new galaxies, it's about discovering meaning. Because in the end, the universe doesn't just tell us how small we are, it tells us how precious we are.